Nature has given us an ability to see the world around us, not only the ability to see but also to think and analyze. With the help of the light, we are able to perceive the colorful world around us, like trees, buildings, animals, the sun. We see uncountable number of stars in dark sky. As our understanding develops, our curiosity to know leads us to think how many things exist around us in which forms. This is not only our curiosity, the human beings since the early time pondered about how big is this universe, what are the components of the universe, how it was formed and evolved, and what is the future of this miraculous, beautiful universe. Hello everyone, this is Abdul Quddus, Assistant Professor at University Polytechnic, Aligarh Muslim University, Aligarh. Today we are diving into one of the most mind-blowing topics of all time, the formation and evolution of the universe. Among many existing theories, we will discuss the widely accepted and reasonable theory, the Big Bang theory. In just couple of minutes, we will explore how everything we know came to be, from the Big Bang to galaxies, stars, and even you. Let's get started. About 13.8 billion years ago, the universe began with the Big Bang. Imagine all the energy and matter in the universe compressed into a single infinitely dense point. Then boom, at around 10 raised to power minus 43 seconds after the Big Bang, particles began to be pair produced from radiation. At this stage of the universe, there were equal number of matters and antimatter particles, which is different from the present universe where matter dominates over the antimatter. Further, in a short period of time, it expanded faster than the speed of light, a process called inflation. Think of it like blowing up a balloon. The universe went from smaller than an atom to the size of a galaxy in less than a blink of an eye. Crazy, right? Right after the inflationary period, the universe was so hot that quarks and gluons, the building blocks of protons and neutrons, roamed freely. This period is called the quark epoch. It was like a cosmic soup of particles were too hot for anything stable to form. Around this time, a process that is not yet well understood took place, a process of baryogenesis, which created an axis of matter over antimatter. As the universe cooled, quarks combined to form protons and neutrons. This marked the beginning of the hadron epoch. Now we are starting to see the building blocks of atoms come together. Next came the lepton epoch where electrons and neutrinos were the dominant particles. The universe was still too hot for atoms to form, but things were cooling down. Imagine a universe filled with a fog of electrons and neutrinos, pretty wild. Oof. After the lepton epoch, the universe entered the photon epoch. Photons or light particles dominated the universe, but it was still too hot for atoms to form. This period set the stage for one of the most important events in a cosmic history, the formation of the first atom. About half million years after the Big Bang, the universe cooled enough for electrons to combine with protons, forming the first hydrogen atoms. This process is called recombination. As this happened, photons were finally set free, creating the cosmic microwave background, a snapshot of the early universe that we can still detect today. For the next few hundred million years, the universe was a dark, foggy place. There was no stars or galaxies, just a sea of hydrogen and helium gas. This period is called the cosmic dark ages. It is like the universe was taking a nap before the real action began. Gravity started pulling gas together, forming the first stars and galaxies. These stars were massive and burned brightly, but they didn't last long. When they died, they exploded in a supernova, scattering heavier elements like carbon, oxygen, and iron into space. These explosions were like cosmic recycling plants, creating the building blocks for planets, life, and even you. Between 500 million and 1 billion years after the Big Bang, the first stars and galaxies began to ionize the surrounding hydrogen gas. This period, known as the epoch of reionization, made the universe transparent to light. Imagine the universe turning on the light for the first time. Fast forward to today, and the universe is a vast, expanding wave of galaxies, stars, and planets. Our Milky Way galaxy alone has over 100 billion stars, and there are trillions of galaxies out there. As astronomers studied galaxies, they found that their rotation could not be explained by visible matter alone. This led to the discovery of dark matter, an invisible form of matter that interacts only through gravity. Dark matter provides the gravitational pull needed to hold galaxies together, and there is the wild part. The universe is still expanding, and it is doing so faster and faster. A mysterious force responsible for the expansion of the universe is called as dark energy. Dark energy makes up about 68% of the universe, while dark matter accounts for 27%, leaving just 5% of ordinary matter. In the upcoming videos, we will explore the dark matter and dark energy. So what is next? The fate of the universe depends on the balance between dark energy and gravity. Scientists have a few theories. One possibility is the big freeze, where the universe keeps expanding until everything is so far apart that it starts burn out and the universe becomes cold and dark. Another theory is the big crunch, where gravity pulls everything back into a single point, possibly leading to another big bang. Or there is the big breakthrough where dark energy tears everything apart. We don't know for sure, but it is fascinating to think about. So there you have it, the incredible story of the universe from the Big Bang to today and beyond. It is a story of creation, destruction, and endless wonder. You are made of stardust and you are part of this amazing cosmic journey. Until next time, keep exploring. See you in the cosmos.